Okay, next example, the lifetime of a certain battery. So it's the same setup. We have the same mean and standard deviation. This time we're going to look at what proportion is expected to last more than 220 hours. So we're going to start by setting up our probability statement. So we want the capital X, meaning the observation is greater than 220. And then we're going to set up a graph that illustrates this. So draw a standard normal model, and I know it's got to be larger than this value somehow. Next, I want to find the z-score for this. So the z-score is observed minus expected divided by standard deviation. So it's the same 1.33, but this time we want the other side of it. So we calculated the less than probability. Now we want the greater than probability. Now, the great thing is we already have the number we need. When we went to the calculator and typed in from the last example the lower bound, we got a probability of 0.9082. This time we want the greater than piece, so we just want to do 1 minus that. So the likelihood of it lasting more than 220 hours is about 9% of the time. Okay. Let's change up the question then. So again, given the same numbers of mean of 200 hours and standard deviation of 15, how long must a battery last in order for it to be in the top 5%? Okay, well, believe it or not, this is actually a different type of question than what we've done in the previous examples. We're going to work it out the same way, though. Different calculator skill will come up in a second. So we'll start with our probability statement. The probability that the observation, the capital X, is greater than, this time I don't know, but I am told that it's in the top 5. So greater than meaning I'm in the upper part of the normal curve. So when I look at the sketch of this, I get that. Kind of got ahead of myself here. So you're probably wondering what that 1.645 is. We'll get there. Anyway, so my picture means I'm looking at the top 5%, so that means 95% is less than it. So when I set up my z-score calculation, I get, and this is where I'll talk about where the 1.645 came from. Let me pull out the calculator again. Okay, so when I go to the calculator, I am given that the area above is 0.05, and I can figure out that the area below is 0.95. The calculator only views things in terms of less than. So we always have to adjust if we're looking at greater than a particular value. So I want to first figure out where this 1.645 came from. Where'd that z-score come from? So when I go to distributions and I go to, this time I want inverse norm. Inverse norm is I have a probability, I want a z-score that corresponds to it. So when I get inverse norm, the area below is 0.95, and I get a mean of 0 and a standard deviation of 1. And I'm just going to hit enter, and I get 1.645, which is what we had a second ago. Now let me kind of show you what happens if we use the 0.05. So the calculator is really silly. It doesn't really understand greater than or upper 5% versus lower 5%. So had I kept it as 0.05 when I type that in, what it's going to do is it's going to give us the exact same number, but it's going to give us a negative. Now that negative simply means we're on the lower end of the graph. So if you do make that mistake, you can still use the number. All you got to do is remember that it's positive 1.64, not negative 1.64. Anyways, so the calculator, it's just easier to think about it in terms of less than. So now that we have that, I can set up my equation then. So I've got a z-score of 1.645, the observation being x minus 200 divided by 15. So fill in those parameters, and then I'm just going to solve this equation. Let me go back to my calculator here and kind of move that over. So to solve this, I want to multiply the z-score and the standard deviation. So 1.645 times the 15. And then, sort of, how do I get rid of subtracting 200? Well, I'm going to add 200 to it. So if I add 200 over, I get a number of, an observation of 224.7, essentially. So there we go. That means the top 5%, anything that lasts longer than 224 hours would be considered top 5% here. Okay, let's change the question again and sort of look at a different skill. And this time we switch the mean and the standard deviation. Yay! All right, so we're going to say that the heights of female students are normally distributed with a mean of 65. What standard deviation, what would be the standard deviation of this distribution if we're given additional information of that 18.5% of female students are shorter than 63? Okay, so we're going to go through our four-step process, and we'll kind of fill in the blanks as we go here. So first up is to figure out a probability statement, and that, so if our observation is less than 63, the probability of this happening is 0.185. So far so good. I just don't know standard deviation. But next up is to draw a picture, and let's kind of stop and talk about where might, let's see, we got 63 here, and I want anything less than it. I know the area being 0.185. So where did this negative 0.9 come from? Well, remember our calculator does z-scores in terms of less than. So that probability is 0.185. Let's go back to our inverse norm. And again, probability less than 0.185. Okay. And, okay, so then from here I'm just going to hit enter. And I get actually negative 0.98896, but negative 0.9 will be close enough for us. And so then I'm going to fill in the z-score formula. Is this what I'm solving for? It's the standard deviation. So 63 minus 65. Observed 63, I expected 65. And we working backwards to find that standard deviation. So let me go to my calculator again to kind of help out with this. So sort of think of it like a, well, let's see, 63 divided by 65, that's negative 2. And then I want to divide by that negative 0.9. So let me kind of show you in the calculator what's happening here. So they did negative 2 divided by negative 0.9. And the standard deviation of 2.22 shows up. So one way to work backwards from that. So just kind of backtrack here. Make sure you're aware of the different types of things that one could ask you. I could ask you to find a probability, in which case that's a norm CDF. I could ask you to find a z-score, and that's inverse norm. And I could ask you to find a standard deviation, in which case you'd have this process here. So just make sure you're aware of the three different types of problems that can occur when we're looking at a normal distribution.